Welcome everyone. Um, so today we have the August month's community sync call. Um, my name is Bhavani Sudha. I'm a PMC member of the Apache Hudi project. I'll be driving this call today. Here is our agenda. So we have short community updates, and then we have a user spotlight from Jayasheel and his team. We'll be discussing about how to implement slowly changing dimension tables with Apache Hudi and Spark. After that, Ethan from One House and Apache Hudi committer will describe like what's going on in the latest RFCs, what is coming in point 13 release, etc. And then we can open up for questions. So community updates, last month we had 58 authors contributing to all the PRs landed. We had 143 merge pull requests and 87 closed issues. And the highlight is we had point 12 released. There is a link attached in the slide. You can also head over to the website to check the release highlights and all the cool features that went into point 12. Please check it out, give it a try, and also let us know if you see any issues. We passed 2,200 Slack users and 3,500 GitHub stars. And the next releases and ongoing RFCs will be discussed in detail by Ethan. So those are for the updates. I'll invite Jayasheel to take over and walk us through his blog and discuss the next topic, which is implementation of slowly changing dimensions with Apache Hudi.
Hi, good morning and good evening or good afternoon, everyone, wherever you are. I'm Jayasheel, working as staff engineer at Walmart Global Tech India. I have with me Isha and Prashant, who are my colleagues, and we work in the same team. And we have been, can you go to next slide, please? Yeah. So in Walmart, majority of the data engineering teams, we are set up this way right now, what you're seeing, the upper part, especially in the, the customer analysis and the DCA team, where we call them. We are already on the Google Data Platform, and we have a lot of source system. I'm just taking an example of Kafka. How we are set up right now is we ingest the data from Kafka in real time, and then we store all our data in GCS, in GCS buckets. And as and when there is a business need based on different flows and different architectures, it can be near real time, or it can be batch. We ingest that data which is stored in the GCS bucket in our Dataproc clusters. So what is the thing that we are doing on Dataproc is majority right now it's Hive. We are using Hive to get the data from a raw zone, that is our GCS, uh, convert it into various use various transformations and do different types of castings, those kind of transformations, and then we put the data into something called a staging area in BigQuery, and we use our own built-in pipeline which is on Apache Beam. And once it goes to the BigQuery, we use the classical SQL methods for upserts. So right now our consumption is on BigQuery, and all the reporting services, ad hoc users, business, everything, they use BigQuery to query the data. What we thought, right, was we had to reduce our consumption or our ETL on the BigQuery and bring it to something which can scale up without having a large cost. So that is why we did a benchmarking of different tools, Hudi, Iceberg, and Delta, and then we finalized Hudi because of various aspects. And when we started our program, everybody were doing their own kind of updates and upserts however they wanted. We were tasked with a special requirement where we had a slowly changing dimension table which is type 2. where we had to maintain the history of old records with some audit columns. We had to keep effective start timestamp, end timestamp, and a kind of an indicator column, which would say whether that record is actively, current active indicator, current active record. And initially, when we started with Hudi, what we found was Hudi can take delta data frame, and it can, update, can upsert. Hudi will not know which historical record we need to keep and which record that needs to get obsoleted, right? So what we had to do was we have to come up with a logic where we provide Hudi the exact kind of data frame where it will tell Hudi that if I take this data frame and if I push it into the table with an upsert, it should give me the exact snapshot of whatever is required at that moment. It is not something that we could go with the point in time query with Hudi, because we wanted to show if a record has changed, say 10 times in past few months, we wanted to see all the record at once. And we wanted to see only one record which is active at that moment, but other one also we wanted to see, but they are not active. So that kind of complexity we wanted to achieve. And we managed to do that uh, by providing a data frame which was written by our own, classical SQL approach. And that is what we published in Medium, so that it's a very easy example that we took, and we published. So probably anyone who has similar use cases can take this as an example and build on top of that. Can you go to the next slide, please? Okay, so I already spoke about the requirements that we had. That is, we wanted to keep a history of all the records along with the existing record which is being used, which is an active record or a most recent record. And we wanted to keep certain audit columns to tell which is the record and when and where and during which instances the record went through the updates. We also had some cases where we had to you know ingest multiple updates for a same record on the same day. And also it should contain, when I select star from the table, it should not only give me the snapshot data, it should show the entire history of one particular record. Next slide, please. So how we did it? Uh, in case of uh, multiple updates for a same record on a single day, we used window functions on Spark, especially rank and lead functions, to obsolete the next the current record when we get a new record. That I have not covered in the Medium because that probably will become too complex, and probably we will let the team take the engineering teams, whoever is going to work on it, take care of that. Probably in future we'll publish it, but at the moment we have taken a straightforward approach. You get one update per day. So how we did it? It was a very simple thing. We provided Hudi with the data frame which had our inserts and our updates both together. But the thing was, we gave something called as active updates, and we gave another set of data called inactive updates. So active updates are those which you get from the delta, and inactive updates are those which you already had in the target, which will get obsoleted. So we gave this as an upsert, and Hudi was intelligent enough to take it and put it in the table as we needed it. Can you go to the blog, please? Yeah. So please scroll down. Yeah. So can you click on the view raw? I'll just go through the example now. So we had a table, and we have a couple of records in this, and each record had a effective start timestamp and effective end timestamp, and it had a column active indicator. And right now we have a fresh table. Then there is just we inserted the data into the Hudi table. Can you go back to the blog, please? Yeah. So how we did this? It's a straightforward. Initiate the Spark shell with Hudi Maven coordinates, and then just create the table from Scala, and then you just add the data to the bucket, and can you yeah, so that's how our table which was earlier. So this is our delta table, so where we have changed few attributes for few rows, and we have a new record as well in this. If you can probably show side by side, tab 3 and 4.
Is it visible or
No.
okay? I think I need to do a new share. Okay. Is it visible now?
Yeah, yes, thanks.
Mhm.
So yeah, so if you can see now, on the left hand window, can you just scroll to the left, please? There is a attribute which I want to show. Okay, it's covering. Okay. Yes, that is enough. Yeah. So yeah, if you can see the product 4565 with seller ID, there is a change in the name of the product name. So the attribute has changed, and also 1234 product ID, where you had a product name of Tide 2 liter, it has changed to 5 liter. So these are our slowly changing dimension attributes. And you also have a new record, that is sticky notes 3315. So let's see how we can use this data to implement our slowly changing dimension table. You can continue with the blog. Okay, so the first step is we ingest the data into data frame, and then first we will identify our insert record. So how do we do that? Standard Spark method. We join the delta data frame with the target data frame on the key columns. Right now I've taken two attributes, seller ID and product category, as key columns, primary key columns, and doing a left anti join, or you can do a left join and select the target as null, and instead of that, Spark allows you to do a left anti join, and you can get the records which are insert directly. So now my insert record is ready. Sorry, insert data frame. So in that data frame, what I'm going to do is I'm going to introduce two new columns. They are effective end timestamp and row number 16, and effective and the active indicator. So effective end timestamp, because this is an insert record, it will have a timestamp till year 9999, just to make sure that it's a very long record. And that's the current active data. So it will have an active indicator as 1. And this is how the final data frame will look like. Yeah. And then we have uh, update data frame. So what we do right now is let's prepare an update data frame. So first we will take the delta data frame and join it with our target data frame, which we have already. And what we do here is we will select all the columns from our delta table, that is line number 7, and all the columns from our target data frame. So now you have both the data side by side in same row. So you just get the delta and the target and just keep them side by side. This will now be split into active and inactive updates. Next, can you scroll down, please? Yeah. So we have the structure delta attributes and we have target attributes, both in the same row. So now what we will do is, from the target, wherever we have received the stage data, that is the changes, we will obsolete the data from target by doing effective end timestamp as the effective start timestamp of the delta -1. So we'll just whenever the delta arrives, so till then it was active, and after that it became inactive. That's what we are going to put, and make that active indicator as 0. That is what we have done in the next the gist code. So if you can see, please scroll up from line number 1. Yeah. So the active updates, they'll contain all the columns. If you can see, they are all from stage underscore. That means they are from the delta table. It will contain all the columns, and it has a new column that is effective end timestamp with the year 9999 and active indicator. So these are the ones which have matched the inner join with your target, and it's exist in the target, and you are going to take them and you are going to put them as a your active updates, which will be your recent records. And if you go to line number 22 onwards, here what we are doing, we are taking all the columns from the dataset which created in the step previous to this, that is the where we have merged the delta and the target together. So I'm going to take all the target columns, and then what I'm going to do is the effective end timestamp, right? That effective end timestamp, I'll be assigning a value which is coming from stage effective start timestamp and interval of -1 second. So that creates a value of whatever the time it has arrived on the delta -1 second. And then I'm going to make the active indicator for this as 0, so that this record will become obsolete. So now you have two separate data frames, update active and update inactive. So now totally you have three data frames. One is insert and the other two are active and inactive. Can you please come down, scroll down? Okay, so what I'm going to do now, I'm going to union all these three and put it in a single data frame. So now this is ready for Hudi. So now we will process data frame to Hudi, and we will use our primary keys as record keys and effective time start timestamp as our pre-combine. And then active indicator is our partition right now, because if any user wants to query the latest records, all the active records, or I mean all the fresh records or recent records which is already active, they are all in one partition, so the retrieval is very fast compared to having a date partition or something. So that is why we have used partition as active indicator in this example. And when we use the Hudi upsert logic, and we write it into our final table. So Hudi will take this, and it will, wherever there is a record key found, it will just update. And thus our final data, if you can go scroll down. So you can see here, scroll to the right, please. Yeah. So here, yeah, that's it. So whatever we had in the source, in the first table, they have been updated. Wherever we had those attributes with the changes in the dimension, those attributes have been updated, and the active indicator is made as 1 for them. And the old record, the active indicator has changed to 0. And if you can see, the effective time end timestamp also has been changed, the last two records. So this is how we have done it. And in our real project use case, we had multiple updates coming in for same record on the same day. So while calculating the update data frame, we have used window functions before sending this data to Hudi. And this we have not yet productionized. Probably in a couple of weeks after thorough testing, and we want to test this with a large volume of data, we will be productionizing, and probably will update the Hudi community how it went. But this is right now, we have tested multiple times with whatever our test data. It's working as expected. And special thanks to Isha and Prashant who have executed this. I just guided them on different steps and different logics. That's all. I'll take the Q&A questions at the end.
All right. Do you want to take the questions towards the end of the
I
sync?
mean, I'm okay. Like if there is if there is a general Q&A session, or I can take even now also.
Yeah, well, maybe we can spend like 3 minutes or so for any questions.
Yeah.
If not, we can go ahead.
Yeah, sure.
So I have a question in the example. I'm not sure if the example is actually simplified compared to the actual data set you guys are working with. But from the example, what I glean is that you're updating the partition value when you're trying to delete, like that update inactive.
Yeah.
So
Yeah.
for example, initially a record was inserted to partition 1, which is like the active indicator 1.
Yeah.
Later, when you get an update, you're moving it to partition 0.
Yes, the record is moving from one partition to another.
So you're using regular index or global index?
No, for this we have right now used regular index. So
Bloom index, regular Bloom index. Okay.
yeah, so we tried with merge. I think Isha, can you speak more on that? When we tried Bloom on the merge, what happened?
Yeah, so basically, even if we do not want to use a partition table, right? We had a use case where we had multiple keys, complex keys right now. And I think there is an open ticket where we do not use complex key with non-partition tables. That is why we had to keep one column as a partition column, which for this use case, we have kept it as active indicator.
Oh, I see. Okay.
Yeah.
Okay. Okay. Sounds good. Thanks.
Actually, can you like give us some insight on how you plan on querying these tables? Like you mentioned, like retrieving the versions is the key, but what, like, can you give like some sort of examples on like how you're using these?
Yeah, I also have a similar question, which is how you can actually retrieve history of any record in the final snapshot. I don't have good clarity on that.
Oh, you want to say like when I query for a particular record, how does it show me all the? Yeah, it's like a
history.
When we query for a particular record here with say using primary keys, it just gives me all the records which have gone through the changes, not just the snapshot data. It will show me even starting from the day when the data got inserted, right? It will show the data inserted date as effective start timestamp, and the next update when it came -1 second as the effective end timestamp, and it will have active indicator 0 for that.
Gotcha.
Oh, you're okay. You're using complex key where you have one of your record key field as your effective end time or something. Okay.
Yeah.
Okay. Now
Yeah.
Thanks. Sorry, Sudha, I hijacked your question.
No, I just wanted to understand like the query consumption part, like how this is used and like use case.
Okay, so this is on one of our Walmart's sellers data. So where we are working, we are from one of the reverse logistics team of Walmart, and we will have some configuration for sellers data, like a seller, what all the products that he is selling, and what all the attributes that he will keep changing in for a product. Say for example, this quarter he may have a return period of 30 days for a product, but he may change that to 15 days after a couple of months. So imagine a user or a customer, he buys an item, and he will have a 30-day return period, and then once in the same next week or something, the seller changes your return policy, right? And after that he has to return the product. What the Walmart agents customer care, or even in these Walmart platforms like app or walmart.com, what they will see is this product return period is probably over, he cannot send it. So that time there will be a dispute raised. Then what the returns team, the business team, what they do is they'll go and see the history of this return period, when this return period was changed. And that is why we need to keep the history of the data here, because they'll query based on the product ID and the seller ID and the organization of the seller, and they'll see he has recently changed the return window, but when the customer made the purchase, it was still 30 days.
Got you. It's very interesting use case. Thanks for sharing the insight.
Yeah.
All right. Any other questions?
There's not a question as such, but a suggestion. Since
Yeah.
in your query, I assume mostly it's going to be predicated on product category or something. Did you guys consider doing a clustering based on product category to
Uh,
improve your query performance?
no, not yet. We have not reached there where we have enough data to test it right now. And
Okay, okay, got it.
our record keys are around, I think, 5 to 6 attributes are there. Uh, Complex. It's a complex key generator, and
Yeah.
they are all based on different hierarchy of the seller. So they are all string columns, but they are still, they will have some data, even special characters. So we do not know how is it going to behave. Whatever we have tested right now is with very small amount of data. So probably once we get that enough data to test, we will come to know the real picture.
Okay, okay, thanks.
All right. With that, I think we can take more questions towards the end. And I'm inviting Ethan to walk us over the latest RFCs and what's coming up in 0.13 release.